this is isoelectronic species and reactivity. First, let's review reactivity. Metals tend to lose electrons, which is why they have low ionization energies. The easier a metal loses an electron, the more reactive it is. And we refer to this level of reactivity as a metal's metallic character. Nonmetals, on the other hand, tend to gain electrons, which is why they have high ionization energies. This is why ionic bonds are typically between metals and nonmetals, because metals tend to form anions and nonmetals tend to form cations. Here are the periodic trends again. You'll notice that metallic character and non-metallic character are opposite of each other. Metallic character increases going down the periodic table and going to the left. Non-metallic character increases going up and to the right. What are ions? Ions are formed when a neutral atom loses electrons to form a positive ion, which is called a cation, or gains electrons to form a negative ion, which is called an anion, in order to achieve a complete octet. For example, we have sodium and fluorine here. Sodium has 3 electrons, 1 valence electron. Fluorine has 9 electrons, 7 of which are valence electrons. So sodium is going to give its 1 valence electron to fluorine. Boom, boom. Now they have full octets. And this is Na plus and F minus. Isoelectronic species. Ions that share the same electron configuration are called isoelectronic. So if we look at oxygen here, oxygen's electron configuration is 1s2, 2s2, 2p4, and it forms the ion O2-, whose electron configuration is 1s2, 2s2, 2p6. Fluorine's electron configuration is 1s2, 2s2, 2p5, but it forms F-, which has the same electron configuration as O2-. Thus, we can say O2- and F- are isoelectronic because they have the same electron configuration. So, a neutral atom becomes smaller when it loses electrons and larger when it gains electrons. For example, if you look at calcium, when it loses electrons and forms Ca2+, which is a cation, it becomes smaller. Phosphorus, when it gains electrons and becomes P3-, it becomes larger. And these are the radiuses in picometers. So why is this? When an anion is formed, you add electrons, and thus you increase the number of electron-electron repulsions. And this is why the radius increases. When a cation is formed, you're removing all of the valence electrons, which is why the number of electron shells decreases and the radius decreases. So lastly, we're going to be talking about comparing ions in an isoelectronic series. So in an isoelectronic series, the number of electrons is the same, which is why we look at the number of protons. So the greater the nuclear charge, the greater the electrostatic attraction between the electrons and the nucleus, which causes a decrease in radius. You can think of it as the stronger nuclear charge pulls in the electrons more, which is why it's smaller. So if we take a look at this isoelectronic series, this is an isoelectronic series because all of these ions have the same number of electrons. And if you look at Al3+, you'll notice it's the smallest because it has the greatest nuclear charge. Aluminum has the greatest number of protons, so it has the greatest nuclear charge. And then the ion with the smallest nuclear charge, N3-, is the largest.